Hey, amazing people. We're going to look at an example here of being able to determine whether or not a function we are given is a probability density function. Now, for this function here, you can see that it's given in a piecemeal fashion. This function is 3x squared over 26. Now, one of the key things here is it's only given a select domain. That select domain is between the region of x equals 1, and then we've got the other one, which is x equals 3. And so it's only between those two parts we're looking at it. So if we think about how we graph it, now if you look at this graph, you can see that it's only got a select region. Now it's like this graph has had one end of it cut off, and then it's had the other end of it cut off as well. Now we're only focusing on those points deliberately between 1 and 3 here. We don't want to focus on any other parts. Now, one of the key things we need to remember is that a PDF always has an area of 1. So PDF has an area of 1, okay, representing 100% all the results. So therefore, with this here, what we're going to have is 1 being our area is going to be equal to the integral of 3x squared over 26, and it's going to be between 1 and 3, because we're only looking at that shaded region we have in this graph here. And by doing that, that will give us a result of 1. So we'll go through this now. So as we go ahead and integrate this, what we're going to end up with, so I'm just going to focus on the right-hand side here. We're going to have 1 is equal to, if I integrate this, make it a bit easier for me, I'm going to remove the fractional part of it because it just makes it easier to integrate then if I've only got 3x squared. And as I integrate this now, I'm going to have 1 is equal to 1 over 26. I'm only integrating the 3x squared at this point, so that's going to become x cubed, still between 1 and 3. And what we end up with is we're going to have 1 equals 1 over 26 outside the brackets of 3 cubed minus 1 cubed. We work this out, we have 1 over 26. Again, this is 27 minus 1. That becomes 26. So when I have 1 over 26 times 26, that gives me an answer of 1. So therefore, I can say this is a probability density function. Okay, I have another example now. In this one, we're told a function is given by f of x equals a to the x squared, and it's defined by the domain 0 and 5. So we need to find the value of a for this, which is a probability density function, so a PDF. So remember, a PDF has an area of 1. So based on that, what this means is I'm going to have 1 is equal to the integral. Now we're told the domain here. So this domain, which is 0 and 5, is telling us that x is somewhere between 0 and 5. Okay, so we just have to remember this region here. So that's going to be what I'm integrating between. And what I'm going to integrate is ax squared dx. Now, as I work through this, I'm able to factorize a little bit just to make it a bit easier. So I'm going to take a outside of the integral because it's a constant value, whatever it may be. We just don't know it yet. That's what we're trying to find here. And I'm just going to integrate x squared just to make it something a bit easier to focus on. So this then is going to give me the integral x squared becomes x to the power 3 over 3. And we're doing between 0 and 5. As we keep going with this, we're going to have 1 is equal to a. Now in this time, we're going to substitute in. So I'm going to have 5 cubed over 3. And I'm also going to have minus 0 cubed over 3, but that ends up being 0. So I'm just going to leave that part out here. So 1 is still equal to a. Outside of 5 cubed is 125 over 3. And I've got this. Now, in order to complete it, I need to have a by itself. So I'm going to divide on this side by 125 over 3, divide by the other side by 125 over 3. And this is going to then give me, remember when you're dividing by a fraction, you flip it up the other way and then multiply. So this is going to give me 3 over 125. So for this function, it's going to be defined as f of x is equal to 3 over 125 x squared. So this is the probability density function that we have for a domain of between 0 and 5.